Mass M is positioned on a 30-degree incline. It's kept stationary by a string that's parallel to the incline. Determine the tension in the string. So we are going to talk about this problem, and there is mass M on the incline, and this is 30 degrees, and this is the mass M, and this is the string, and this is the tension force. So we can determine this tension force by using this. So the tension force is and this is the normal force. So this is the answer. A 3 kilogram mass lies on a rough horizontal surface. It's attached to a 1 kilogram mass by a string draped over a pulley. One minimum coefficient of friction is needed in order for the blocks to remain at rest. So we are going to talk about the forces we can find, and this is gonna be the friction force, and this is force of tension, and this is also force of tension, but it has opposite direction, and this is force of gravity. So force of gravity is equal to force of friction, and this means so this is gonna be the answer. A projectile is launched with an initial velocity of 50 meters per second at an angle of 30 above the horizontal. Determine the y-coordinates of the projectile's initial velocity of y-coordinates. This is the projectile motion. initial velocity is 50 meter per second, and the degree of this is gonna be 30 degree. So we can make this first diagram. So 25 meter per second is the answer. Two forces act on a 5 kilogram mass. A 16 Newton force pushes the mass in the positive x direction, and a 12 Newton force pushes in the negative x direction. Determine the resultant net force acting on the object. So there is two force on a 5 kilogram mass, and one of them is 16 Newton, and this is to the minus x direction. This is 12 Newton force, so the total force is so this is gonna be the answer. A mass is displaced upward along 30-degree incline. When it reaches the top of the incline, the mass has a vertical height h of 2.4 meter. What is the displacement of the mass as measured along the incline? So this is going to be used this is the incline, this is 30 degree, and this height is 2.4 meter. So we are going to use this formula. This is 30 degree, then this is right angle, this is 60 degree, then we can apply to the this, and this is this, so we are going to find this, then just multiply 2 to the 2.4 meter, then 4.8 meter is the answer. A mass initially at rest experiences a constant acceleration and is displaced a distance, resulting in a final speed. What would be the final speed of the object if it moved the same distance but with twice the acceleration? So there is kinetic equations, and we are going to use one of these. And we are going to use this one. So the initial velocity is 0 meter per second. Then velocity is this. And we are going to apply 2a to the a. Then and this is same with this. So this is the answer. Determine the magnitude of acceleration of the object when time t is 4 seconds. Determine the displacement of the object during the 5-second time interval. So we are going to find the magnitude of acceleration, and this means the slope. So firstly, the slope is the acceleration. Yes, the slope is the magnitude of acceleration, and this is same with this derivative. So this is in the answer, and secondly, we are going to find the displacement of this graph. So this is going to be time, and this is going to be velocity. And then we are going to find the distance. So this area is 2 multiply 20 and 1/2. So this is 20. And we are going to find this area. So we are going to multiply 3 and 20. Then this is 6. So the total algebra, the final answer is this and this and this. This and this. A 6-kilo person rides in an elevator that is accelerating upward at 1 meter per second. What is the apparent weight of the person? Apparent weight meaning force, normal force acting on the person. So we are going to make force diagram. This is gonna be normal force and this is gonna be force of gravity. So 616 Newton is the answer. If a ball is thrown straight upward with an initial velocity, it will reach a height of h. If the initial speed of the ball is doubled, what will be the minimum height? So we are going to choose one of these equations. And we are going to use these. And this is so the answer is 4. A ball is thrown horizontally from the edge of a 5-meter tall building. It lands 25 meters from the base of the building. With what initial speed was the ball thrown? So this is the building of 5 meters tall, and we are going to throw this ball, and this is going to falling. A ball thrown horizontally So we are going to find the distance to the x direction. So this is the equation. Yes, this equation is come from this kinetics equation. So the answer is 25 meters.